Hi, hello everyone. Welcome to Scholars Hub at Home. I am Joanne Hui, Alumni and Events Officer at the Faculty of Environmental and Urban Change at York University. Thank you for joining us for today's lecture, Do Clear Skies Mean Clean Air? Pandemic Lockdowns and Their Influence on Air Quality with Dr. Cora Young, Associate Professor in the Department of Chemistry in the Faculty of Science. It is my responsibility to acknowledge the land that I am on. Because we're all not gathered in the same place, the land I'm about to acknowledge might not be for the territory that you are on. Please take the responsibility to acknowledge the traditional territory that you are on. The website nativeland.ca is a good resource for this. As a member of the York University community, I recognize that many Indigenous nations have longstanding relationships with the territories upon which York University campuses are located that precede the establishment of York University. York University acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaranto has been caretaken by the Anishinaabeg Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. This territory is subject of the Dish with One Spoon Wampum Belt Covenant, an agreement to peacefully share and care for the Great Lakes region. Before we introduce our speaker today, I'd like to give you all an exciting university update. Nominations are now open for this year's York University Alumni Awards, which will be held in November. Every year, the York U Alumni Awards recognize 4 alumni that have achieved the extraordinary and are working to write the future by creating positive change in their fields. This is your opportunity to nominate an outstanding alum to receive this special recognition. Nominations are open until March 31st, and the link to the nomination page will be included in the chat if you'd like to read more details or download the nomination form. Now, we'd like to conduct a quick poll before each lecture. Today's question is, how would you rate your knowledge regarding the topic of today's presentation? Let's give you a quick moment to enter the information on the poll on your Zoom screen. Great. So we hear that a majority of people here today are somewhat informed at 71%, minimally 21%, and very high. Thank you for sharing your pre-event knowledge. So what we're going to do now is I'm going to go over some instructions if you need any help with the Zoom webinar. So feel free to click on the Q&A button at the bottom of your screen to enter your question. Our team is ready to help you. The same button can also be used to submit questions for our guest speakers to answer during the Q&A period following today's presentation. Please note that all of your questions and comments are visible to the panelists and staff working behind the scenes. We ask that you keep your comments relevant and respectful. So as I mentioned, today's talk will be given by Dr. Cora Young. Dr. Young is an associate professor and the Guy Warwick Rogers Chair in Chemistry. She is an atmospheric chemist whose research focuses on the sources and fate of environmental pollutants. She is also the recipient of the 2022 Environment Division Early Career Research Award from the Chemical Institute of Canada. Dr. Young's work has been featured in numerous media outlets, including CBC's Quirks and Corks and the Nature of Things, and the BBC. We are so pleased she can make it today and join us today. Welcome, Dr. Young.
Thank you, Joanne. Now, let me just share my screen here. Okay, hopefully you can all see that.
Thank you. I will be back after the presentation for the Q&A, so thank you so much.
Okay, thanks again for the lovely introduction, and thanks to everyone for being here today to talk a little bit about air quality and how the pandemic might have affected air quality. So Some of you may not know that York University has actually been a global leader in atmospheric chemistry. We were one of the first institutions to have a research cluster focused on this topic. So many important advances in atmospheric chemistry have actually been made at York University. And hopefully I can help to continue this tradition. Okay, so the chemistry that happens in the atmosphere is actually driven by a very small fraction of the molecules we find surrounding us. So most of us know that the atmosphere that we breathe every day is made primarily of nitrogen and oxygen, with small components of unreactive gases like argon and carbon dioxide. But there's a small fraction of those molecules that are reactive. So that's less than 0.2%, but that really drives the chemistry that happens in the atmosphere and the chemistry that drives poor air quality. So when I talk about air quality, I like to show these two photos. I took these photos in Los Angeles, actually when I was part of an air quality study, and you can clearly see the difference that air quality makes. So on the left-hand side, we have a relatively clear day. You can see the nice mountains. This photo is actually taken in Pasadena. And on the right-hand side, we have a much lower visibility day. You can hardly see these mountains a few kilometers away. It's quite clear that the picture on the left represents a poor air quality day. So how does this actually happen? So we have a couple ingredients that we need to make poor air quality. The first is emissions. Most of these emissions come from our own activities, although the natural world can contribute as well. So the chemical emissions that I'm going to talk about today are organic chemicals and NOx. So organic chemicals, this is a complex mixture of chemicals emitted from numerous sources. So many of them come from human activities. So every time we burn something by driving or heating our homes, etc., using solvents like paint, industrial activities, cleaning our homes, personal care products. Basically, if we're using something that smells, there's a very good chance we're emitting organic chemicals from that activity. And the biosphere also emits organic chemicals, that distinctive pine smell and the smell of flowers. These are all organic chemicals that are being emitted into the atmosphere. So there are some individual organic chemicals that are toxic, but the major impact of organic chemicals is actually the chemistry that they can do in the atmosphere. So the second class of molecules that we emit through our activities is NOx. And this is the short form for nitrogen oxides, and it's comprised of two molecules, both of which contain nitrogen and oxygen atoms. So the first is nitric oxide, NO, a single nitrogen, a single oxygen atom. Second is NO2, nitrogen dioxide, a single nitrogen and two oxygen atoms. So we consider these as a kind of a group because they quickly interchange in the atmosphere. So they flip between NO and NO2 due to chemical reactions. And in most areas, most NOx is present as NO2. NOx is emitted from any combustion process. So when we're driving, when we're heating our homes, etc., we are emitting NOx into the environment. And NO2, which as I mentioned is the dominant fraction of NOx, is associated with negative health effects. And it's a regulated pollutant in many regions, including Canada. So NO2 is associated with respiratory disease, chronic obstructive pulmonary disease or COPD, and acute lower respiratory illness or ALRI. NO2 is actually visible at high levels as a brown gas. So there are some places in Southern Ontario where you can actually see NO2 coming from smokestacks. So not all smokestacks emit combustion gases, but those that do sometimes look brown, and that's because of the NO2 that's being emitted. All right, so these emissions can themselves contribute to poor air quality, particularly the NOx. But if we add another ingredient, we can end up with even more pollutants formed. So the second ingredient that we need is sunlight. And once we add sunlight, we can kickstart chemistry that happens in the atmosphere and form two more pollutants. And those pollutants are particulate matter or aerosols and ozone. So particulate matter and aerosols, we've heard a lot more about aerosols recently because of the airborne transmission of COVID. that happens via respiratory aerosols. So you may be familiar with this term. Basically, particulate matter and aerosols are synonyms. These are tiny droplets that are suspended in the atmosphere, and the ones we're concerned about for air quality purposes are typically formed from reactions of chemicals that have been emitted by our activities. Particulate matter that has a diameter less than 2.5 microns, or PM2.5, these are particularly toxic and have been attributed to millions of premature deaths every year are attributed to exposure to ambient PM2.5. So this is considered to be really a global health concern, and there are many governing bodies that are really concerned about this and trying to reduce particulate matter in order to improve health outcomes globally. So particulate matter is a regulated pollutant in many regions, including in Canada. And PM, as you probably know, is readily visible to the naked eye. If it's present in substantive levels, it basically looks like a haze. The second thing that can be formed, pollutant that can be formed through chemistry, is ozone. And ozone is a molecule that's comprised of 3 oxygen atoms. And it can be a little bit confusing to think about because not all ozone is created equally. We have our good ozone and we have our bad ozone. So I'm showing you here just a little schematic of a cross-section of our atmosphere. So on the vertical axis, sorry, we have the height above the ground, and on the horizontal axis, we have the abundance of ozone. So you can see that most of the ozone is well above our heads, 15 to 35 kilometers above the surface of the Earth in the stratospheric ozone layer. And the ozone that's our good ozone. We definitely need that. It protects us from UV rays that come from the sun that would otherwise decimate organic molecules on Earth, including the ones that make up our bodies. So that's our good ozone. When we get down to the surface of the Earth, that's where the bad ozone is. That's the pollutant ozone that can be formed from these chemical reactions. So it's formed from emitted chemicals. We call it a secondary pollutant because it's not emitted directly. It's formed from reactions of things that we do emit. So the formation is complex and it's nonlinear. So sometimes if we increase emissions, that means we increase ozone. Sometimes if we decrease emissions, we end up with more ozone. So this means that underlying chemistry is complicated and really important to understand if we're going to effectively regulate this pollutant. Ozone, like some of the other pollutants I've talked about so far, is associated with negative health effects like respiratory illness and COPD, and it's a regulated pollutant in Canada and many other regions. Ozone is an invisible gas. So this means it can be present in high abundance and we can't tell. So if we look again at these photos from Los Angeles, you can say on the right-hand side, what we're seeing is poor air pollution that's characterized by high levels of particulate matter. On the left-hand side, we can say probably there's relatively low levels of particulate matter, but in terms of ozone, we have no idea between these two pictures. Another thing we have to consider when we're thinking about air pollution is that it is not distributed equally. So air quality in some parts of the world has improved dramatically over the past few decades. And in Canada, we're fortunate that we enjoy very good air quality, and that air quality has continued to improve, particularly in Toronto, where there's been just huge improvements in air quality over the past 15 to 20 years. So one of the reasons we've enjoyed these improvements is because we've spent a lot of time studying air quality in mostly Western cities. And that means our understanding of what's happening to generate poor air quality is quite good. And that's allowed for effective regulation and improvement of air quality. If we go to other parts of the world, air quality remains very poor and contributes to very negative health outcomes. So the photo I'm showing you here on the left-hand side is a photo of Delhi in India. And air quality in India is very, very poor. So 9 of the 10 most polluted cities in the world are in India. And this is attributed to hundreds of thousands of deaths, particularly because of high particulate matter and ozone in the cities there. So a challenge with thinking about air quality is that we can't always directly translate our knowledge from one place to another. So we understand air quality quite well in places like Canada, but there are cultural differences and meteorological differences between Canada and other places that mean we can't translate that knowledge directly to improve air quality in other places. So we really need to look at locations experiencing poor air quality directly to understand what's driving the air quality conditions in those areas. So how do we actually do that? How do we understand the chemistry of air quality? Well, we want to do, like any good science experiment, what we'd like to do is perturb the system in a controlled way and then see how that system responds. So in an ideal world, we would perturb the atmosphere in a known and controlled way and see how the chemistry responds. Well, of course, that's not possible. We can't just turn a knob and turn the sun up and down or turn an emission up and down in the real atmosphere. That doesn't work. So we have to try different approaches. So one way we do this is by trying to control the conditions, by bringing the atmosphere into the lab the best we can. So trying to simulate the real atmosphere in our labs, and then we have control over the concentrations of gases and things like this. So on the right-hand side, I've shown you, this is a smog chamber. Basically, it's putting the atmosphere in a test tube in the lab, and then we can control the chemistry happening in there. The other approach we can take is to try to simulate the real atmosphere using mathematical models. So if we simulate the chemistry and the meteorology in a model, we can turn, the sun up and down. We can do all kinds of things that we can't do in the real atmosphere. But of course, the real atmosphere is complex, and we can only do so well when we try to simulate. So the other approach that we use is to make measurements of the real atmosphere and look at changes with time of day, weather, etc. So we can look at changes between night and day, for example, when the sun is on versus off, at least in our part of the world. But this isn't a truly controlled experiment because there are lots of other things that change between night and day, not just the presence and absence of the sun. So it can be quite complicated to interpret this type of data. But we have a really nice, we have an air quality research station on the top of the roof of the Petrie Science and Engineering building. That's what I'm showing you here in this picture on the right. And that's where my research team, as well as others, make these types of measurements regularly. The pandemic came along and created a perturbation. So we all lived through this. We know what happened. I'm just showing you a graphic description of this on the right-hand side. This is mobility data collected by Apple from their cell phone users, people who are entering directions. Basically, that data is aggregated and used to generate these plots. So this data is for Canada over 2020. And you can see that there's a big dip in mobility from walking, driving, and transit that happens around April 2020. So lockdowns across the world changed human behavior. And when we change human behavior, particularly with respect to transportation, this is likely to change emissions. And if we change emissions, that's likely to change air quality. So the pandemic created this perturbation that can allow us to probe air quality a little bit more. So first, looking at emissions. So I mentioned NOx is something that's emitted directly. And this is something we expect to change as human behavior changed. And NOx is something that we can see relatively easily because we can see it from space, from satellites. So we saw that NOx decreased in most urban areas, and I'm demonstrating that here on this map. So what we're looking at is the difference in NOx levels between April 2020 during the pandemic and April 2019 before the pandemic. So when we see these cool colors, that tells us that April 2020 had lower NOx. And when we see warm colors, that tells us April 2020 had higher NOx. And you see really intense cool colors are concentrated where we have big urban areas. And so this is what we would expect as people's transportation needs reduced. We saw much less NOx being emitted, and therefore NOx concentrations going down. Now, when we look at the particulate matter and ozone, remember these are secondary pollutants in many cases. So they were variable. So the emissions changed them sometimes, but not so much other times. So in some areas, they stayed about the same. In some areas, we saw decreases, and in some areas, we saw increases. So looking at the concentrations of emissions is not itself enough to determine how air quality will change, we have to consider all of the ingredients. So that includes the chemistry and that includes the meteorology. So you may have seen some of this at the beginning of the pandemic. Dramatic changes were observed in air quality in India. This was all over the news. I'm showing you here an example from the BBC where they were talking about the big improvements in air quality that had been observed when the lockdown started. And of course, this was a big story, partly because the air quality in Indian cities is so poor and really impacts the health of people who live there. So on the left-hand side is a terrible air quality day in Delhi, and on the right-hand side is a day during the lockdown. So what we were interested in doing, and this is where our study comes in, is to understand the underlying chemistry that might be happening in this perturbation. So along with Lee, who's a postdoctoral researcher here at York, and Yash, who's an undergraduate student, we looked into this a little bit more. So we took some data from on-the-ground monitors in several locations in Delhi, as well as other Indian cities. And we saw how this changed as the lockdown came about. And we considered the weather and the chemistry, as well as the levels themselves. So starting with NOx, because we know this is a direct emission, we saw a very large decrease in NOx. So I'm showing you here a plot. On the right-hand part of the plot, we have the last 3 years of NOx levels. And on the left-hand side are the NOx levels observed during the lockdown. You can see there's a very large difference there. And this was attributed, based on our study, to decreased emissions, as we would expect, but also because of changing meteorology. And so you might ask how meteorology can affect a direct emission. And the reason is that because we're looking at on-the-ground monitors, these are located at a very fixed point, and therefore the wind direction actually makes a big difference to what we measure. So imagine the wind is coming from a really polluted area with lots of emissions. We're going to see high levels of NOx, whereas if the wind direction changes and comes from a cleaner area, we're going to see lower levels of NOx. And so this was part of what actually happened here in terms of these measurements. We saw a change in wind direction. So the emissions that changed during the lockdown, just because of the lockdown, we estimated at about 1/3 to 1/2 of the change in NOx that we saw. Now, what about particles? So the change in visibility that made the news everywhere, we know is likely mostly due to particles. And as we expected, when we looked at this data coming from monitors in Delhi, we saw this significant decrease in particulate matter. But when we looked at this more closely, we actually could attribute most of this decrease to changes in meteorology. So the lockdown coincided with abundant rain, and rain basically acts like a scrubber of the atmosphere. So the particles can dissolve into the falling rainwater and they essentially get washed out of the atmosphere. So the good news story here wasn't so much the lockdown, but the weather. So certainly blue skies are great, but the lockdown didn't do as much to improve PM 2.5 as initial stories in the media might have led us to believe. Now, when it comes to ozone, we saw something different. Ozone increased dramatically in Delhi. And when we looked at the data, we saw that this was actually attributed to the decrease in NOx. So remember earlier I mentioned that we can have this nonlinear effect. So NOx can go down and ozone can actually go up. This isn't always the case. It depends on sort of the characteristics of the chemistry. But in Delhi, decreasing NOx leads to increased ozone. So this has some important implications for policy, because reducing NOx is one thing that policymakers do to try and improve air quality. That's what's improved a lot of the air quality that we have in Canada and in the US, for example, is reduced NOx. So it's important for policymakers to be aware that by reducing NOx, they may be increasing ozone, which is potentially a concern. We also noticed that there was an increase in sunlight, so increase in visibility from the reduced PM 2.5. So we saw these nice, clean blue skies, and that meant more sunlight, which means we can have more chemistry and therefore more ozone. So because ozone is an invisible gas, the clear skies that we saw portrayed in the media weren't really as clean as we might have been led to believe, because we had high levels of our invisible pollutant ozone. So while this isn't necessarily as what we learned means that the story might not have been such a good news story as initially portrayed, I think we've actually learned quite a bit about the chemistry in Delhi, which means that that information can be used by regulators to improve air quality. So this was quite a fun project for us to work on while we were locked out of our labs during the pandemic. So when we published this work, it was picked up by several Indian news outlets, which is great. That's where we want the data to end up. And it was also featured on an episode of The Nature of Things. So on the left, I'm showing a photo that was taken during the filming of that. That's me as the star. This was my first time doing something like this, so I now have a new appreciation for the effort that goes into this type of process. So I have a few take-home points here. Air quality is a complex function of emissions, weather, and chemistry. Major perturbations can help us to understand the underlying chemistry of air quality. And the pandemic lockdowns caused air quality in Indian cities to change. Most pollutants decreased, but ozone increased. And with that, I'd like to thank you for your attention, and I would be happy to answer any questions that you have.
Thank you so much, Dr. Young, for that very timely and informative talk. So please feel free to stop your screen share at this time so that we can move forward with the Q&A from the audience. So we now have time for questions. So audience, please use the Q&A function at the bottom of your screen to ask any questions that you may have. For those that are joining us on Facebook, you're welcome to also submit any questions or comments through the comments section of the video as well. So we're going to start off with our first piece. So you talked a little bit about the influence of lockdowns on air quality. So what about the impact on the climate?
Yeah, so there was an impact of the lockdown on climate. We saw that greenhouse gas emissions decreased by, 5 to 7%, which is actually also interesting and useful because it tells us how much our individual behaviors actually can contribute to the emissions of greenhouse gases, right? As we all stayed home and nobody flew anywhere, we see that actually might not have as big of an impact on greenhouse gases as we might have been led to believe, and that systemic change is really what's needed to reduce greenhouse gas emissions.
Thank you so much for sharing. We actually have another question coming in from our audience who mentioned that they were in Hanoi at the beginning of 2020 and they saw a big visible difference there. So they're wondering if there's any data on other cities.
Yeah, so there have been quite a number of studies that have looked at air quality during the pandemic because it was such a distinct perturbation, let's say. I don't want to frame the pandemic as being a positive, but there's the silver lining is that it did allow us to learn quite a bit about air quality. Yes. So there are lots of studies that have come out of Asia, as well as Europe and North America, looking at air quality, and the results have differed from place to place, but there's certainly a lot that we're learning from this.
Okay, great. So one of the other questions that came in is there a governing body that will help establish rules and regulations about air quality? What are your thoughts on that?
Yeah, so the World Health Organization basically sets guidelines for what air quality levels should be. Now it's up to individual countries and provinces, states to actually figure out how to try and meet those, and they're not binding. They're really, the World Health Organization provides those as guidelines. So individual countries and other entities can decide to regulate that or not as they choose.
Okay, great. Um, our audience is wondering if there is a particular country that does it best, in your opinion, when it comes to protecting air quality. Would you like to share a couple of those?
Sure, yeah. So actually, California has really been a leader in air quality protection. So some of you who are a bit older in the audience might remember that Los Angeles used to have absolutely atrocious air quality. And really that's where a lot of air quality studies began. Because the air quality there was so bad, there were a lot of studies, and then the California Air Resources Board started to regulate. And actually, we can thank California for some of the air quality benefits that we experience in other places in North America, because car manufacturers, in order to meet California's guidelines, they don't make different cars for California and everywhere else in North America. So we all kind of reap the benefits of that.
Beyond California, are there any others that you might suggest for the audience?
Yeah, so Europe, the European Union has been quite progressive in recent years, in particular in making changes, and yeah, they've done quite a lot. Yeah, but California is really they get the gold star.
Thank you for sharing. So one of these questions came in from the audience as well. So since the lockdown was for a short time, what effect would be expected if the time frame was to be extended? Would it be of importance?
Yeah, so the pollutants that we're talking about for air quality don't live very long in the atmosphere. So that means that, and that's why we see air quality change quite a lot from day to day. So it's really that day's emissions that make a difference more so than long-term trends. So I would expect we just would have seen more of the same if the lockdown had continued. Of course, that would depend on how industry was affected by the pandemic lockdown as well.
So we talked a little bit about the pandemic. Let's say, for example, as if we weren't always to be in a pandemic, what could have been done to help improve air quality overall?
Like just in general, yeah, what could we do?
Yeah.
So one of the things that has been very effective in North America is regulating vehicle emissions and regulating smokestacks, basically. So industrial emissions and transportation emissions are the biggest source of pollutants that lead to poor air quality. Now, these regulations have led to decreased NOx and decreased organics. But what we're actually seeing over the past 10 years or so is an increase in our own personal care products contributing to the emissions of organic compounds. So instead of emissions from tailpipes contributing to organic compounds, we're seeing a real growth in cleaning products, deodorants, perfumes, all kinds of scented stuff. These are making a big difference in terms of air quality. So one thing you can do to help out air quality is buy unscented cleaning products.
So it would be the creation of those products would be one of the contributors to that.
Creation and use, yeah.
Creation and use.
Yeah.
Thank you. All right, so go unscented.
Go unscented, yeah, it's better.
Okay, so here's a follow-up question for LA. So one of the sorry, I'm just going through this. So actually, the LA basin has had bad air quality throughout observed history, including pre-industrialization. The combination of geology, the inversion layer, and wind or lack of all contribute to this.
Yep.
Isn't this a tainted example due to these factors?
Sorry, I missed what you just the last bit.
The last bit was the audience member was asking, isn't this a tainted example due to the factors that they were sharing?
Right. Well, every place has its own unique meteorology and topography. It's really the topography of LA because it's a basin that leads to poor air quality. But the fact is people still live there. And so we want to improve air quality regardless of their weather and topography. And so by that means it's even more important for them for the emissions to be controlled in a place like that. So there are lots of examples across the world of places that do have topography that make them more susceptible to poor air quality. And that just means that the task is more challenging to get air quality to safe levels for people to live. So yeah, I mean, Los Angeles is a challenge because of the topography and the meteorology. They have to work really, really hard to reduce the poor air quality conditions there. Yeah.
So another question that's coming in was, how would you rate Canada's performance in managing air quality?
A loaded question, yes. So Canada has done quite well, I think. In particular, the air quality gains in Ontario from phasing out coal-fired power plants is huge. So that's driven a lot of the improvement in air quality we see in the city of Toronto. I remember, 15, 20 years ago, we had smog days all the time in the summer, and we hardly ever have them now. Maybe 1 or 2 a year. Like that's a major improvement. So I think Canada has done well. We're not alone in this because a lot of the emissions that affect our air quality do come from the US. So air is a transboundary
yes.
it's a transboundary concern. And so we have to work together with the US to really improve air quality, particularly for places close to the border.
So there's lots of opportunities for collaboration and partnerships in managing that. Thank you for sharing. So I was wondering if you can outline if there have been other type of disruptive events in the past that has provided us the opportunity to learn more about air quality. Would you care to share a little bit about that?
Yeah, so there are things that we can use that we have used in the past to understand this. So actually this first one I'm going to share is not disruptive, but it's more human behavior driven. And that's the difference between weekdays and the weekend. So atmospheric chemists have used this for decades, looking at the difference between weekday and weekend, because emissions are different on weekdays than they are on the weekend. And so we can actually use these and compare them to see how, to try and understand the underlying chemistry. So that one's been really, really important. Things like the recession have actually also provided an opportunity. So emissions actually decreased quite a bit as a result of the recession. And this provided some additional insight into air quality chemistry.
Thank you. So you mentioned that York is a leader in this research. Would you like to share a little bit about other great work that's being done by your fellow researchers and faculty members?
Yeah, sure. So yes, and not all of it is related to air quality. There's lots of great work being done. Actually, indoor chemistry is a new big one that's particularly important during the pandemic. So yeah, my colleagues have been working on understanding the drivers of poor air quality indoors, which are different than outdoors, still driven by emissions, but the emission sources are different. There's lots of work on contaminants, on climate and greenhouse gases. There's lots of work being done that's all really impactful, I think.
So actually, we just got a quick question that came in. Do you have any takes or observations on electric cars and their contribution?
Yes, that's a great one. And so there's always some discussion about, because when you drive an electric car, the emissions are not from the car itself, but from the electrical generation. So of course it does matter where your electricity comes from, how those will contribute to poor air quality. But one good thing, one major factor is that it's much easier to control emissions from a single power plant than from thousands of individual cars. So even if your electricity comes from a dirtier source, it can still be a benefit to drive an electric car, because controlling those emissions from that single power plant is much easier than to try and control emissions from all of our different vehicles. I actually used to live in Newfoundland, and people would remove the catalytic converters from their cars, which really decreases the efficacy of the emissions reduction, and there was no law against that in that location. So, you know, that's a difficult thing to control, what people do individually, but much easier to control or to regulate a single power plant industry or the industry of power generation.
So one of the questions that I would like to ask you is, as we look into, worrying about climate change for future generations and talking to future generations or younger generations, sorry, is what I was trying to say. Is there any tips that we could share with them to talk a little bit more about how to take care of the earth and the air? Are there any particular resources that you advise that we can share, especially with the younger generation?
Yeah, so my major advice is actually to talk about it. It seems that, in particular, climate change is kind of a taboo subject. People really feel that it's going to be divisive, so they don't like to bring it up. And the reality is that lots of people are concerned about climate change, but they think they're the only one. So talking about these issues and bringing them, like letting everyone know what the concerns are, is actually considered by many climate scientists to be the best thing that we can do to combat climate change. Because our individual actions aren't enough, we saw that from the pandemic, we need to advocate for systemic change, and the way to do that is to have a large group of people acting together, right? Either voting or pressuring politicians or whatever. These types of actions are what's really needed to make change in air quality and climate.
So you shared a little bit about us helping facilitate conversations about it. Are there any of your resources that you would recommend that they share amongst one another, or any other events that you think would be a really great opportunity for people to take part of?
Yeah, so there is a really great climate scientist who's a Canadian, actually. She works in Texas, named Catherine Hayhoe, who has a wonderful TED Talk that I would strongly recommend. She also has lots of other resources, but that's where I would start with talking about climate change in particular, but a lot of what she suggests applies to other environmental issues too.
Thank you so much. So we're going to start wrapping up the Q&A at this point, but I'd love to invite you to share a couple words if there's any other information that you want to share with our audience today and beyond for those that are watching later.
Well, I'd just like to thank all of you. I'm happy that so many of you care about air quality and want to learn more, and I encourage you to share your concerns if you have them with family and friends, because that's how we will make a difference.
All right. Thank you so much, Dr.
Thank
Young,
you.
for spending time with us today and sharing your very important research. We very much appreciate your time. Right. So for those of you who would like to share today's session with family and friends, it will be posted to our YouTube page at youtube.com/YorkU alumni. You can also watch past lectures that you may have missed from our Scholar Hub series as well. We now have one more poll question for you. So after Dr. Young's presentation, how would you rate your knowledge of today's topic following the discussion? It's going to pop up on your screen right now, and I'll give everyone a moment to respond. And then I believe the responses will be shared with everyone here today. Great. So we see that 52% feel that their knowledge has much improved, 43% have somewhat improved, and 5% was mostly the same before. So thank you so much for sharing your post-event knowledge. We really appreciate learning a little bit more about your knowledge. Okay, So, I do want to give a shout out to our next Scholars Hub at Home session, which will be taking place in partnership with Glendon College on Wednesday, March 30th, where we'll be joined by Assistant Professor Emily Laxer from the Department of Sociology at Glendon College. She will be speaking at her session about populism, legality, and the politics of diversity in Canada. So, you'll see information on the screen here. Following that, we also have another session on April 13th, where we will invite Zachary Spicer, Associate Professor at the School of Public Policy, with his presentation, Small Town Short Work Week, Evaluating the Effects of a Compressed Work Week in Zora, Ontario, Canada. You may register for each of these events and learn more at yorku.ca/alumni and friends. And the link is being dropped into the chat for you to copy and paste over to your browsers. So that brings us to the close of our Scholars Hub session today with Dr. Young. Thank you all so much for joining us. We hope you had a great time and we wish you well until our next session. Thank you all.